talking about the boost converter, and we're going to calculate the critical inductance, and this will help us choose the inductance value, so what value of L in henries do we want for this inductor to get the type of operation that we want. So for example, continuous conduction mode, boundary conduction mode, or discontinuous conduction mode. So to do that, we need to look at the waveform of the current through the inductor. Here we have the waveform of the inductor current, and during the switch on stage, it's increasing in current, it hits its peak value, and then decreases. So the peak value here is going to be 2 times this average value. So because it's a triangle, the average is exactly half, and the peak value is going to be twice that, so 2 times the average inductor current value. For the boost converter, we have to figure out what is the average inductor value here. Look back at this diagram. The current coming into the inductor is the exact same as the input current. So during both phases of the switch, it's always going to be the same as the input current. So actually we know that that is going to be equivalent to the average input current. We can use this equation to know how high this peak value is going to be in boundary conduction mode. So the average value for the inductor is same as the input current. So assuming you know the specs of your system already, you know the input current, you can use that value, and you know that the peak value that you want to see in your inductor is going to be twice that value. So now let's go to calculating the inductance value. We start with the inductor equation. So VL equals L di dt. We're going to look just at one switching period. We can either look at when the switch is on during this period section, or when it's off during this section. And we just have to pick one. I like to pick, for this one, the boost converter, the first one, because we get exactly V in when the switch is on. The voltage over the inductor is going to be V in, which is a very simple number. So we're going to look at just when this stage switch is on and the inductor current is increasing to its peak value. And during that phase, we can change the delta d dt to a delta I and a delta t because they're constant. Now we want to solve for L here. So let's rewrite that. So L equals your VL delta t over delta I. So here's our general equation. During the switch on phase, we know that VL is simply VI. So it's going to be VI. The delta t is going to be this time period. So this is going to be dt. And then delta I is whatever our peak value is going to be. So it's going to be peak. Now we can use this to calculate the critical inductance, which is going to be exactly in boundary conduction mode. So L critical is equal to, so the input voltage dt, that stays the same. So now we can plug in the peak inductor value, and for boundary conduction mode, like drawn here, we know that this peak value is going to be twice the average inductor value, which for a boost converter is twice the input current. So we can put twice the average input current here. And this, if you know your input current based on your specification, you can use this equation to determine the critical inductance. If you're not sure what that is, for example, you have this circuit, you're not given the input current explicitly, then you just have to calculate it, but we can do that really quickly. If you want to get the input characteristics based on this, you have to, in this case, assume the input power and the output power are the same, which means it's an ideal converter. So P in equals P out, and our P in is going to be voltage times current, so V in, times the average I input current here, and that's equal to the output power. Since our resistor is our load, we know the output power is V squared over R, so V out squared over R. We want to calculate for this, so you can just rewrite this as V out squared over VI R. So then we can take this value, plug that into here, and we can get a new expression for the critical inductance value. Here we'll get VI dt on the numerator and 2 V out squared. Then these two are going to go to the top, so we're going to get an I VI squared and an R here. So this is another expression if you have a resistive circuit like this and you just need to know your output voltage and your resistor value, and you can plug that in to get your critical inductance value. Remember, L crit means boundary conduction mode. L greater than L crit means continuous conduction mode, and less than L crit equals discontinuous conduction mode. So depending on what type of mode you want to operate in, you can find the critical inductance value and then adjust your inductance value depending on the mode that you'd like to operate in. So that's how you calculate the critical inductance value for a boost converter.